3, 2, 1. Hello, in this video I want to help you distinguish units from variables and also tell you something about numbers that we use in algebra. This is just some vocab basically. We use a lot of letters. For example, m shows up a lot in physics. And sometimes it shows up like this, length equals 12m, and sometimes it shows up in an equation, like y equals mx plus b. This is more of a math thing, but still. And we call this a unit, and we call this a variable. But how do you know if it's a unit or a variable? Basically, if you see a letter attached to a number, so length equals 12 meters, for example, this number and this letter are part of a pair, in this case it's going to be a unit. So units are attached to numbers in the sense that a unit combined with a number turn into a physical measurement, which is what we deal with in physics. Whereas if you have a letter just hanging out not next to any numbers in an equation, like this, y equals mx plus b, this is going to be a variable m. In physics this would probably be mass, but this is a math problem, so this is actually the slope of a line. But it's a variable if it's in an equation totally distant from numbers. Now that's not necessarily true. For example, right here, if I say f equals 10 kilograms times 2 meters per second squared, this f is a variable. But this kilogram and this meters per second squared, these are both units, not variables. In a more conceptual level, a unit is something that, so like the number and the unit, these combine to become a single measurement. And this number and this unit, these combine to become a single measurement. So they're about measurements and properties. But this f, this is actually a placeholder where you put a measurement. So this f is a variable because eventually you're going to want to replace it with some number that you calculate, and then you're going to need to put units on it, which could be kilogram meters per second. So that's going to be the units. So the fact that these both are supposed to go into the f column, the force column, this is a placeholder for a measurement or a property. That's why it's a variable. So variables are placeholders and units go on the actual measurements that we make. So sometimes it can be a little bit tricky to figure out. For example, T equals 30C. Now this could mean that the temperature outside is 30 degrees Celsius. That's one thing that it could mean. But it could also mean that, I don't know, the torque that you're feeling is 30 times some sort of rotation rate. So this is actually just bad. It's not always super obvious. So normally what we do is in physics we put units in, they're smaller, like that, or we'll put them in parentheses with the measurement. But sometimes it's just very difficult to tell, and you're not going to be asked any ambiguous situations like that. In this case, actually, there's one other thing. So this is a variable that stands for kinetic energy. And you know that because it's not associated with a number. It's not part of a measurement. This is actually a variable too. It stands for the velocity because it's not a measurement. This right here, this kg, that's a unit because it's attached to the 12. So that's telling you that this is the measurement, 12 kilograms. And this thing right here, the 1/2, what is that? Because it's not a variable, right? Because you don't put a measurement in there. And it's not a unit because it's not attached to a number. It is a number. So what do we call that? And if something is not a measurement or a unit, it's just straight up a number in an equation, what we call it is we call it a numerical constant. So a numerical constant is not a measurement, so it's not like 12 kilograms, and it's not a variable because we don't replace it with anything. It's just a number that's an essential part of a relationship between physical quantities. So if you have a number that has no units, it's probably a numerical constant that's used in a formula. So that was it. That was quick vocabulary. I hope that was helpful.